Chapter 11 begins our unit on studying physical science. We are going to start with studying matter and its properties. Picture this. You are working inside an instrument in a laboratory that is 3 stories tall. When your work is done, giant magnets and other equipment will start to hum. Tiny particles, too small to see even with a microscope, will zoom through the instrument at super speed. These particles will smash together, forming new types of matter. Scientists do experiments like these as they study matter. Scientists have been studying matter for centuries. All things around us are made with just a few kinds of matter. Each kind of matter has its own set of properties. Elements. There are more than 100 basic kinds of matter called elements. Elements are the basic building blocks of matter. Elements combine to make up all other kinds of matter, and elements cannot be broken into smaller pieces with ordinary physical or chemical processes. Only a few elements, such as gold, are found in nature in pure form. Most elements are combined to form the things around us. For example, rust is a combination of iron and oxygen. Living and non-living things are made of just a few elements combined in many ways. Each element has its own chemical and physical properties. You can use these properties to identify each element. Chemical properties describe how a material changes into other materials. Physical properties include an object's mass, volume, color, odor, and phase at room temperature. Physical properties can be observed, described, and measured with tools such as rulers, microscopes, thermometers, scales, and balances. More than 3/4 of the elements are metals. Metals have the physical properties of being shiny, bendable, and able to conduct heat energy and electricity well. Here again, in a chart form, are physical and chemical properties of elements. Physical properties can be measured without changing the material. They're able to be seen. These include color, mass, and volume. Chemical changes happen when material changes into other materials. For example, when steel rusts, it is now made up of different materials. Again, more than 3/4 of the elements are metals. Metals have physical properties of being shiny, bendable, and able to conduct heat energy and electricity well. Each element has its own properties. They can be same or different. For example, gold is a metal. It's shiny, bendable, and conducts heat. The same thing goes for silver. It's shiny, bendable, conducts heat, and is a metal. Here's a picture of the periodic table of elements. We are going to look further into this in the next lesson. One physical characteristic of elements is weight. Weight is a measure of the pull of gravity on an object. Spring scales measure an object's weight. We will be using one of these in lab. A spring scale has a spring that stretches or is squeezed together when you weigh an object. The amount that the spring's length changes the object's weight. If an object is too large to hang from a scale, you can add up the weights of all the object's parts. The total weight of the parts always equals the weight of the whole object. Weight changes when the pull of gravity changes. Gravity is not the same everywhere on Earth. For example, the pull of gravity decreases slightly as an object is lifted to the top of a mountain. Therefore, the object's weight becomes a little less. Mass is the amount of matter in an object. The amount of mass affects the weight of an object, but mass is not the same as weight. Moving an object to the top of a mountain does not change the amount of matter in an object. Its mass stays the same. Mass is measured by using a balance, often using units of grams, milligrams, or kilograms. To find mass, an object is placed on one side of the balance. Known masses are placed on the other side. When the two sides balance each other, the total mass of all the known masses equals the object's mass. Some pictures of weight measurements. Volume is the amount of space that an object takes up. Cubic units are used for volume. You can find the volume of a regular box by measuring and multiplying its length, width, and height. So volume equals length times width times height, or volume equals L times W times H. You can also use a graduated cylinder to find the volume of a liquid. Here we can see that this liquid is 7 milliliters, but you can also use a graduated cylinder to measure the volume of a solid object that fits in the cylinder and sinks in the water. First, put a measured amount of water in the cylinder, then put the object into the water. Read the new volume. The difference between the two volumes, the original and the new, is the volume of the object that you placed in the cylinder. Density is a measure of the amount of matter in a given volume. To find an object's density, divide the object's mass by its volume. So density equals mass divided by volume, or density equals m over v. Density is a physical property of a substance. Density is the same for a substance no matter how much of the substance is measured. For example, iron will always have a density of about 7.9 or 7 9/10 grams per cubic centimeter, no matter how large a piece of iron is measured. Because the density of a material is always the same, it can be used to help identify material. Mass and volume. Even though iron is more dense than water, it can still be used to build a ship that floats. This is because a ship is not solid metal. It has lots of rooms and hallways. Most of its volume is filled with air. Because of all this air, the ship has much lower mass than you would find in a solid piece of metal the size of the ship. This makes the ship's density less than the water's density. Here are some examples of densities of objects. Water's density is 1. So anything less than 1 will float on water. So wood and air and ice, their density is less than water, so it will float. Anything higher than the density of water will sink. For example, aluminum, lead, and gold. Here's a picture. Wood is less dense than water, so it floats. A rock is more dense, so it sinks. Here, in this example, if each marble has the same mass, which box would weigh more? What do you think? Why? The box that has more marbles has the more mass per unit of volume. An object is buoyant if it floats. Buoyancy is an important property in boats or balloons. You also want a life jacket to float and an anchor to sink. You would use different materials for each. Whether a certain material floats in a liquid depends on the densities of both the material and the liquid, as shown in the chart before. If the object's density is less than the liquid's density, it will float. If the object's density is greater than the liquid's density, it will sink. A pumice stone has a density less than water's density, therefore it floats. Yen, or money, has a density less than water's density, therefore it floats. And ironwood has a density greater than water's density, as you can see, because it's sinking.